Okay, let's go ahead and go through this problem again from yesterday. I think we made a mistake on it. It should have turned out nicer than it did. So there shouldn't have been any constants on it. So let's take a look. So the first thing we're going to do for critical points is set our derivative equal to 0. So the derivative we found was negative 4x cubed plus 4x. And we set that equal to 0. We took out a negative 4x, which left us with an x squared plus 1 equal to 0. When we do zero product property, we end up with x equal to 0, x squared, sorry, this should have been a negative 1. We took out a negative. X squared equals 1, so x equals plus or minus 1. So those are your critical points. So that was the first thing we had to find. Now we're supposed to use that to find maxes, mins, and points of inflection. So f prime of x, So f prime, that sign chart would have been negative 1, 0, and 1. So this right here would be, we would want to pick something lower than negative 1, so we put in a negative 10 into this right here, which would be a negative out of this. Times a negative would be positive, so a large positive number plus a negative number is going to go negative. Between here and here, we decided to put in a negative 1/2. When I put a negative 1/2 in there, we get negative 4 times negative 1 over 8. And then that's really positive 1/2. When I put a negative 1/2 into here, we get 4 times negative 1/2, which is really negative 2. So that stays negative. Then in here, if I put in a positive 1/2, if I put it in and I think about this here, it would be positive 1/8, so it'd be negative 1/2. If I put positive 1/2 into here, I get positive 2, which means it goes positive. I'm going to put in a positive 10, so that's going to be a large negative number. And this is going to be a large, or it's going to be a positive number that's smaller, so that's negative. I think we made a mistake here. So negative 10 would be a large negative times a negative would be positive, so this is going to be a positive number. All right, so it shouldn't have been zeros in the middle. It should have alternated like that. That's the mistake we made. All right, so now let's fix that up. So the next thing we were supposed to do is decide on maxes and mins. Since we're in first year, let's do maxes and mins and increasing and decreasing. Okay, so for our maxes, so we know that it's increasing from negative infinity to negative 1, and from 1 to, sorry, 1/2 to, no, not 1/2, 0 to 1. 0 to 1. And that's because f prime is positive on these intervals. It's decreasing on negative 1 to 0 and 1 to infinity because f prime is negative on these intervals. All right, then we got to talk maxes and mins. All right, so we know that it goes from a positive to a negative, so that's a max. Negative to a positive is a min, and positive to negative is a max. So again, we want to use those sentence frames I showed you yesterday, so I'm going to write it out, but I have the sentence frames posted for you. So this is 2. We've already done 4. We've done 1. Okay, so we have a relative max at x equals negative 1 and 1 because f prime changes from positive to negative. We know we've got a relative min at x equals 0 because f prime changes from negative to positive. All right, I'm going to get us a little bit more space to write here. Oh, maybe not. Okay. And all right, so now we got to talk second derivative. So we had that our first derivative was negative 4x cubed plus 4x. So to get to our inflection and our concavity, we need to take the second derivative. So second derivative equals negative 12x squared plus 4. Set that equal to 0. So negative 12x squared equals negative 4. X squared equals 1/3. So x equals plus or minus the square root of 1/3, which that's ugly, but it'll work for us. So we're going to put that on a sign chart. So we know we've got negative square root of 1/3 and positive square root of 1/3. All I care about is whether it's increasing or concave up or concave down. So I'm going to pick some numbers. I know negative 1 would be less than this. So I'm going to substitute it into here. Negative 1 squared would become positive 1, so it'd be negative 12 and positive 4, which is negative. I put in a 0 is for sure in between there. So 0 is going to make that go away, so it's going to leave a positive number. Put in a positive 1. Positive 1 squared is going to be positive, times the negative is going to be negative. Negative 12 and positive 4 would be negative. So we know that it is concave up like a cup from negative infinity to negative square root of 1/3, and from square root of 1/3 to infinity, because f double prime is negative on this interval. And then it's concave down like a frown on negative square root of 1/3 to square root of 1/3 because f double prime is positive on this interval. Then we still need to talk about points of inflection. Points of inflection is anytime there's a sign change in the second derivative. So we know that, and we're going to use a sentence frame again. F has points of inflection at x equals plus or minus square root of 1/3 because f double prime has sign changes at these values. All right. We'll look at something similar in the second problem. We're going to talk about this from the graph. This, I don't know that it told us here, or I didn't write it down. This is the graph of the derivative. So this is the f prime graph. So I'm going to draw a sign chart from the f prime graph. So first of all, our critical points from our derivative graph are the zeros. So my critical points are at x equals negative 3.545, 0, and 3.42. So I'm going to draw my first derivative sign chart. So my first derivative sign chart is going to be negative 3.545, 0, and 3.42. I know, and I'm going to look at my graph. I'm below the axis, so I'm negative. I'm above the axis, so I'm positive. I'm below the axis, so I'm negative, and I'm above the axis, so I'm positive. So, for my increasing or decreasing, I know that I'm increasing on negative 3.545 to 0, and 3.42 to infinity, because f prime is positive on these intervals. I am decreasing from negative infinity to negative 3.545 and 0 to 3.42 because f prime is negative on these intervals. And then we're looking at maxes and mins, so I've got a negative to a positive, so that's a max. Nope, that's not right. Let's try that again. So on here, we've got to go from a negative to a positive, so that's a min. Positive to a negative is a max. A negative to positive is a min. So I know I've got f has a min at x equals negative 3.545 and 3.42 because f prime changes from negative to positive, and then f has a max at x equals 0 because f prime changes from positive to negative. And I'm going to erase some stuff so that we can get the inflection and the concavity on this same one. Okay, so now let's talk about the second derivative. So the second derivative, I need to create, I'm going to create a sign chart for it. So you got to think of the first derivative as the original and the second derivative as the derivative graph. So my critical points come from the horizontal tangent. So I'm at negative 2.41 and 1.66. So my graph is going up, I am increasing, so it is positive. My graph is going down, I am decreasing, so it's negative. My graph is going up, I'm increasing, so it's positive. So now let's talk about what that means for concavity and for points of inflection. So we know that it is concave up like a cup from negative infinity to negative 2.41. and from 1.66 to infinity, because the second derivative is positive on these intervals. And then it's concave down like a frown from negative 2.41 to 1.66 because f double prime is negative on these intervals. Then we know that because the signs alternate, that there's points of inflection. So the points of inflection are at, so we've got points of inflection at x equals negative 2.41 and 1.66. because f double prime changes sign at these values.